Hi and welcome to this video where we're going to look at the revision worksheet number 12 for the academic year 2019-2020. So this revision worksheet is based off algebra, so there is mostly mock based questions and some of these are quite challenging, but they identify some really important techniques that you should know. So question 1, solve the equation x plus 1 over x is equal to 10 over 3, where x is an element of the real numbers but is excluded from 0. And the reason that we see that exclusion of 0 is because we have 1 over x. So we know if that was 1 over 0, that would not exist. We can't divide by a 0. So all that's telling us there, it's just saying it can't be 0, and we should know that already. Now, questions like this, you need to really focus on what we have here. So we have an x to a power of 1 and we have a 1 over x. And what that 1 over x means is the power of minus 1. Now, what we would generally do in these questions and how we're going to approach it is we're going to get rid of the fractions. And the reason that we're going to get rid of the fractions is so we can create an equation that we know and we are familiar with, which will be a quadratic, and we'll work with it. But we have to be careful when we create a quadratic rather than when we start with a quadratic. So to create our quadratic, we're going to find the lowest common denominator. The lowest common denominator of 1x and 3 is going to be 3x. So we're going to multiply the whole way across by 3x. So let's start with what we have already. 1 over x equals 10 over 3. So we're going to multiply each piece here by 3x, this piece here by 3x, and this piece here by 3x. So the 3's here cancel, that x cancels, and we're left with 3x squared plus 3 is equal to 10x. Bringing that across, we get 3x squared minus 10x plus 3 equals 0. Now, notice how we've got our quadratic and we can solve that either using our guide number method, just straight into factorization, or we can use our minus b formula. So let's solve that here now. So if we want to use our guide number method, our guide number is plus 9. Plus means the signs are going to have to be the same. So we get a minus 9 and a minus 1, which will give us our minus 10x. So we get minus 9x minus 1x plus 3 equals 0. Take out a 3x that's common, we get x minus 3. We take out a minus 1 and we get x minus 3. And we're left with 3x minus 1, x minus 3 equals 0. Solving that, we get 3x minus 1 equals 0, so x equals a third. Here we get x minus 3 equals 0, so x equals 3. And there are answers. However, you have to be very careful, and like I said at the start, we didn't actually have a quadratic to begin with. So we may find that although we get two answers, both answers may not actually be valid. And that's really, really important for us because we see something similar when we do our third equations. We don't have a quadratic to begin with, we create the quadratic. When we create the quadratic, we have to always think, are both answers valid? So what we have to do in this case, because we didn't start with the quadratic, is we actually need to check and see, are both answers valid? So the first one we're going to check is x equals a third. So we're just going to take our original equation and we're going to sub in a third plus 1 over a third is equal to 10 over 3. So what we end up with is a third plus 3 is equal to 10 over 3. And what that is, it's a third plus 9 over 3 is equal to 10 over 3. So we get 10 over 3 equals 10 over 3. And we say that this is valid. So our first answer there, a third, is valid. So the second one we want to check is x equals to 3. So we get 3 plus a third equals 3. sorry, equals 10 over 3. So we get 9 over 3 plus 1 over 3 is equal to 10 over 3. So 10 over 3 equals 10 over 3. So both of our answers here are valid. So question 2. Root 2 minus 1 is a root of x squared plus bx plus c is equal to 0, where b and c are elements of z, which is telling us they're integers, so they're positive or negative whole numbers. Find the value of b and the value of c, and hence find the other root. Okay, so we know that this is a root, so as soon as you're told a root, we should always write in the same form. X equals root 2 minus 1. Now, we're not used to seeing roots in this form. Generally, we see roots presented to us as integers and we work from there. So presenting here this irrational roots, that root 2, that is slightly different to anything we've seen, but we're still going to treat it the same way. So if we are told something is a root, we know that we can sub it in and it should work. So we get root 2 minus 1 squared plus b times root 2 minus 1 plus c equals 0. So multiplying this out, so this works out, so you can square the first, which gives us 2, twice the first by second, so minus 2 root 2, square the last plus 1, so square is exactly like we'd square our algebra brackets. So we get plus b times root 2 minus b plus c equals 0. So once we've done our substitution and we get this line here, we can clean it up slightly, but not a lot. So for example, we have here a 2 and a 1. That's pretty much all we can have. So we have 3 minus 2 root 2 plus b root 2 minus b plus c equals 0. So that's as clean as we can get it, or it's as simplified as we can get it. And at this point, I suppose we can note that we get two unknown coefficients. So we have a b and a c, but we've only one equation. So we're going to have to solve this in a slightly different way than a normal linear equation. So if you take a look here, we have two different types of numbers in our equation. We have what will be considered our irrational numbers, so anything with a square root. And there's two of those. I'm going to highlight them now. So we have this number here, which is irrational, and this number here, which is irrational. And then we have rational numbers. So these are ones that can be written as a fraction. So we have the 3, that's rational, minus b is rational, and plus c is rational. So if we take a look at that, now having it highlighted, it might be slightly, or it might be clearer to you that we have a minus 2 root 2 plus a b root 2. And that's on the left hand side. However, on the right hand side we have a 0. It all equals 0. So effectively those irrational numbers are going to have to cancel each other out. What that means for us is we can do something similar to what we do with our algebraic identities or our unknown coefficients, where we say that the x squared terms on one side equals the x squared terms on the other, and the x terms on one side equal the x terms on the other. So here we can say, well, the irrational terms, so let's start with the irrational. So the irrational terms must be equal. So on that side we have a minus 2 root 2, a plus b root 2, and that all equals 0 because there's no irrational numbers on the right hand side. Working that through, we can get rid of the root 2's and we're left with b equals 2. So we can do the same thing for the rational numbers. We can say that 3 minus b plus c must equal 0. We already know b is 2, so we can slot that in. So we get 1 plus c is equal to 0, so I get c is equal to minus 1. So our new equation, or our updated equation, is x squared plus 2x minus 1 equals 0. Now, there is a follow-on piece of that question, so do make sure that you're doing all parts questions that are asked, and that is, hence find the other root. At this point here, we have the quadratic, so we can very easily go along and use the minus b formula. We won't be able to factorize this. We can use the minus b formula, where a is equal to 1, b is equal to 2, and c is equal to minus 1, and work through. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And when you work that through, you're going to get two answers. You're going to get minus 1 plus root 2, and x equals minus 1 minus root 2. Now, there's no issue doing that at all. It doesn't take that long to do the minus b, and hopefully you're not making any mistakes while using it so much. There is, however, a slightly different way you could approach that. And that is by looking at the initial root that you've been given. So the root is x is equal to root 2 minus 1. That's what we were given in the question. Because there's a square root in it, we can make a guess that actually that's something that looks like it's come from the minus b. However, we would usually write it the other way around. Minus 1, the whole number first, plus the square root. If that was one of those, if that was one of the roots that we got from minus b, then the second root must be minus 1 minus root 2. These are the conjugates of each other, and you'll see this logic a lot more when we move into looking at complex numbers. There is absolutely no problem, like I said, using the minus b formula and working through what we have, but just if you can see that little shortcut there at the start, it might save you a few minutes. So the next question we have is a third equation. So it's an equation that contains a third or a square root. So solve the following equation. X is equal to the square root of x plus 6. So the first thing we want to do is we're going to get rid of that square root. So how we get rid of the square root is we square both sides. So we get x squared is equal to, now a square and a square root cancel, so that just leaves us with an x plus 6. We now have a quadratic, we know that because we have an x squared, so we're going to bring everything to the left hand side and we're going to let it equal 0. Now we're going to use either guide number or minus b to figure out what are the roots of this equation. So if I'm going to use guide number, we're going to have minus 3 and a 2. Oh, something's gone a little bit wrong. 1 second. Okay, so let's try again. So minus 3 by a plus 2. If I add them, I get my minus 1, which is the number in the middle. So we get x squared minus 3x plus 2x minus 6 equals 0. X is common, so we get x minus 3 plus 2 is common, and we get an x minus 3, and that leaves us with the factors x minus 3 and x plus 2, and that all equals 0. To find the actual roots, or to solve it, we let each factor equal 0, so that gives me x equals 3 and x plus 2 equals 0, so x equals minus 2. And this is the point where a lot of students stop. Now, because of that square root, we have basically created an x squared that wasn't there initially. So although we got two answers, the two answers may not be valid. So the last step in all third equations is to actually check our answer. Are both valid? So x equals 3. If we sub that in, we get 3 is equal to the square root of 3 plus 6, which is 3 is equal to square root of 9, which is 3 equals 3. And that is valid. So we figured out that that answer is good. The next one is x equals minus 2. So we sub that in. Minus 2 is equal to square root of minus 2 plus 6. Minus 2 is equal to the square root of 4. And that is not valid. Now, this often causes a little bit of problems for students because they say, well, If you square minus 2, you do get 4. And that is true. However, when we're dealing with a square root, and the square root is given to us, like in this case, that is asking us the positive square root. If they wanted to ask us the positive and negative square root, they will put plus and minus in front of it, like we see when we're doing the minus b formula. So when you see a square root, that square root asks us the positive square root. So this is not valid. So the only answer we have is x equals 3. And that's worth a few marks at the end, so it's really important that you make sure to check your answers at the end of your third equation. So question 3. X minus 3 is a factor of both of these equations. And that's important because they've given two equations here. It's 3 parts to this question, and they'll come back to that first statement. At this point, you need to really be able to look at a question and identify, well, underneath where it says question 3, it's given me a statement. This statement must be true for the whole question. Sometimes people get confused about what is linked to the question and what isn't, what's part A and what's part B and all this. So this is not split into part A or part B. This is just telling us a statement, and this statement must be true for the whole of question 3. So it said find a value of A. So we have a factor. So if our factor here is x minus 3, by that logic we also know a root. So the root then is x equals 3. So we know that when we have a root, it will sub in and it will work. Now, I'm going to use this equation here because it just has an A in it, while the other equation has an A and a B. So that's not going to be as useful for us. So we have 3 cubed plus 3 squared minus 3a by 3 minus 3a equals 0. This gives us 27 plus 9 minus 9a minus 3a equals 0. Cleaning that up, we get 36 minus 12a equals 0. 12a equals 36. A equals 3. Now, you can, of course, use the idea of the factor here. And that means you could show that x minus 3 divides in, and it will leave us with no remainder. However, I think using the idea of the root is just a little bit easier. Some people don't mind long division, and that's fine, but generally working with the roots, if possible, is always going to be a slightly easier option. But you can, of course, use the idea of division. The second part of this question then says find the roots of these equations. Of the equation x cubed plus x squared minus 3x minus 3a equals 0. Now, we know that this equation can be updated to be x cubed plus x squared minus 3 times 3, so minus 9x minus 9 equals 0. So if I want to work out the roots, I already know one root. So root 1, so we know x is equal to 3, because we knew that x minus 3 was given as a factor. So we know that x minus 3 is a factor, so if we divide x minus 3 in here, we'll be left with a quadratic, which we will be able to solve for the other two roots. So this goes in x squared times. So we get x cubed minus 3x squared. So then we subtract here. This turns to a plus. And we're left with 4x squared. So this goes in 4x times. So we get 4x squared. Bring down our minus 9x. Here we get minus 12x. We subtract, so this becomes a minus. This becomes a plus. And we're left here with 3x. And we bring down our minus 9. This gives us a plus 3. So we get 3x minus 9. And that leaves us with no remainder, as we would expect. So we now have a quadratic x squared plus 4x plus 3, and we want to solve this. So you can use your guide number here, that's absolutely fine. And when you do, you'll end up with x plus 3, x plus 1 is your brackets, and you'll get x is equal to minus 3, and x is equal to minus 1. So the roots, we have 3, so we have root 1, which was x equals 3. That was the one we were given in the form of a factor. We have x equals minus 3, and we have x equals minus 1. Do make sure that you're showing all of your answers here, even the one that you've been given. Depending on the question, if it's not clear, you could lose a mark or two. So it is important that you display all your answers together. So the last part of this question says find the range of values of b for which all the roots of the equation are real. So we don't know what b is. We're not even going to be able to work out b. You can try. We know what a is, and we know that x minus 3 is a factor, so x equals 3 is a root, so we can sub in 3. But when you do that, you'll notice everything cancels and we don't actually get anywhere. So what we're going to do instead, we're going to take this and we're going to sub in our a, which we know, plus bx minus 3b, and we're going to leave it in terms of b. Now, the question has asked us find the range of values of b, so they want us to work out not just one answer for b, but a range of values. So it makes sense that when we try to find a solution or an answer for b, we're not going to be able to get it. So what we do know about this is x minus 3, is a factor. So we know the factor x minus 3. I've already said that x equals 3 is not going to help us. If you want to try it, if you don't believe me, that's fine too, and you'll see that actually it doesn't give us anything, it just everything cancels. So if the root doesn't work, we're going to have to use the factor. So we know that when we divide x minus 3 into this, it's going to give us, it's going to divide in evenly, so it's going to give us no remainder. It's 3x squared plus bx minus 3b equals 0. Sorry, I'll get rid of that equals 0. Don't need it. So it goes in x squared times. So we get x cubed minus 3x squared. Now, when we go to subtract this, notice that both pieces cancel. It's unusual, but it's okay. But what we do need to do then to move on is we need to bring down both pieces here. So the next thing we have is x divides into bx, and that goes plus b times. Gives me bx minus 3b, and the same thing happens. We get nice cancelling. Okay, so that has divided in evenly, and we now have two factors. So we now have x minus 3 is one factor, and we have x squared plus b is the second factor. The question asks us to find the range of values for which range of values of b for which all the roots are real. So here, x equals 3, this is a real root. So we have one real root, that's fine. Now we want to say, well, what about this? We want this to have two real roots. Now, when I say that, in your head, there should be a little alarm going saying, oh, two real roots. I know something about that. And we do. We have a quadratic. Okay, it's not a quadratic trinomial, but it is a quadratic. And that's x squared plus b. And we can use the discriminant. So just a reminder, the discriminant, it's the part of the minus b formula, b squared minus 4ac. It's a bit under the square root. And we know when that's greater than or equal to 0, we have real roots. So working with this quadratic, a is 1, b is 0, notice there's no x term, and c is actually b. So we end up with 0 squared minus 4, 1 times b, greater than or equal to 0. So minus 4b is greater than or equal to 0. So 4b is less than or equal to 0. Remember our rules of inequalities. Change the sign. You have to also change the inequality. Okay. Inequality. So we're left with b is less than or equal to 0. So therefore, when b is less than or equal to 0, the roots of the equation will all be real. And that's important. They'll all be real. So the idea of using the discriminant. So here we have to work with the idea of if we want to figure out if a cubic has real roots or it might have one real root or two real roots, whatever way we want to work it, we know the first one, and generally our first root will always be the integer root that we've been given. It will be the real root, and then we have to work with the quadratic when we divide that first factor in. So let's take a look at question 1. So it says let g of x equal to ax squared plus bx plus c, where a, b and c are real numbers. So g of x is just some quadratic function. Given that k is a real number such that g of k is equal to 0, prove that x minus k is a factor of g of x. Now, let's break this down. So we're given a quadratic g of x is equal to ax squared plus bx plus c. We're told that k is a real number such that g of k equals 0. Now this is important. So effectively what they're telling us here is k is a root. Okay, so they're telling us k is a root, i.e. x is equal to k. So we know when we sub that in, we'll get 0. So we know that that's true. So let's have our g of k here. So we get a k squared plus b times k plus c equals 0. So this is like the first piece of information we've been given in the question. We're told that a k squared plus bk plus c equals 0. Okay. So then they want us to prove that x minus k is a factor. So if we want to prove that x minus k is a factor, we want to prove that anything is a factor, it's always the same way. We want to show it show it divides evenly. It divides in evenly. So that means no remainder. And that's important, and that's kind of going to be our logic we're going to use. No remainder. So let's go with this. Let's have our x minus k. We're going to divide it into ax squared plus bx plus c. So first division is slightly okay. Goes in ax times. So ax squared minus akx. Then we subtract, cancel, this becomes a plus, and we're left with bx plus akx. Now, really what we want to do is we want to take that x, you see that x that's common, so what we end up with is b plus ak times x. And the reason we want to do that is for division purposes. When we divide x into this now, it very easily we can see goes b plus ak. So we get b plus ak times x minus k times b plus ak. Come along, this is subtractions, this cancels, and this becomes a plus. So we're left with c plus k times b plus ak. And this here is our remainder. So that's what we have left over because we've done our division now. So we're trying to show that c plus k times b plus ak equals 0. And let's see if that's true. To make it a bit clearer, let's multiply it out. We get bk plus ak squared. Rearranging it, we get ak squared plus bk plus c, and this is equal to 0. How do I know it's equal to 0? Well, let's go back to this first piece of information that we had. Since g of k equals 0. So we actually had that missing piece, and I think this is where a lot of people struggle. They kind of got the idea, I have to do division. Yeah, the division wasn't particularly nice, but managed to get through it and you got the remainder. It's then the question of, well, how do I show that that remainder is 0? Well, we were only given that extra piece of information, that g of k equals 0. So what we will say is, so since x minus k divides into g of x, just for shortening purposes, evenly, we can say x minus k is a factor. And I think this is a really good one to see, because the idea that x equals k being a root and going straight then into saying, well, then we have a factor. We have a factor of x minus k. We use this the whole time and we don't really question it. We kind of go, yeah, that's true. And this is really a very good proof of saying, well, why is it? I don't think you'd ever be asked to prove it now, but now at least you've seen it. So part 2 of this question, x minus t is a factor of this. Show that p is equal to minus t cubed all over 2 times t plus 2. Now, there are 2 methods to doing this, and what I would generally say when there are 2 methods, especially when the 2 methods are either using the factor, which we've been given, or the root method is 99% of times much easier. You can, of course, use long division, but the long division here, given the number of letters, becomes very, very complicated. Sometimes people forget the idea of the factor and the root when we throw it into letters. They see it very easily when there's numbers, but not so much when it's letters. So to work with our root, we say 2x minus t is equal to 0, so 2x is equal to t, so x is equal to t over 2. That's my root, because our factor was 2x minus t. Now, if you do the long division, that's fine. I'm not going to do it here, but I am going to use the idea of the root. So I have 2x cubed plus px plus p. So when I sub in t over 2, everywhere there's an x, it will equal 0. Now, that is much more straightforward than trying to work with the long division. So the first thing we're going to do is we're going to cube out this fractions. That's t cubed over 8 plus pt over 2 plus p is equal to 0. Cancelling this down, I get t cubed over 4 because the 8 and the 2 cancel here, plus pt over 2 plus p equals 0. Let's multiply the whole thing by 4 just to get rid of the fractions, make it a little bit more straightforward. Plus, 4p equals 0. Now, look what we want. We want to show that p equals. So there's a p on its own. However, you'll notice that the p appears twice in ours. What that means is we're going to have to get the p's together in some way, and we do that using highest common factor. So the first thing we're going to do is we're going to get rid of anything that doesn't have a p, and that is the t cubed. So we get minus t cubed. Then we're going to use, I suppose, a more common factor than highest common factor, because we don't care if there's something else common like the 2, we just want the p. So we're left with 2t plus 4 is equal to minus t cubed. So now to get rid of that, we divide both sides by the bracket. So it's 2t plus 4. Now take a look at what we want. It's very similar. The only thing we need to do now is to take out a 2 from the bottom line. We're left with t plus 2, which is exactly what you want. Done, as requested. So this is a lot more straightforward than using the idea of long division. So do be careful. Always kind of question and see, well, if I have a factor, can I use the root? Now, we did a question on worksheet 13 where it wasn't possible to use the root, so we had to use the factor. We had to do long division. In some cases, that will be it. But where possible, try to use the root. You'll find it will simplify your answer quite a lot. Now, question 2 from this, I'm going to do it in 2 different ways because I'm conscious that some people have focused on one method more than the other. Because this is an equation, because there is an equals there, sometimes people use a slightly different method than what we would use for if it was an inequality. So generally we see these modulus, so these 2 straight lines, these modulus symbols, we see them more with inequalities than we do with equations. So generally I would suggest using the same method for both, not to get confused, not to do anything too crazy then when you get into the inequalities. That would be my advice. I sometimes think the less you have to do, the better. So if you only have one method to remember, that will work for both. So anytime you see a modulus, you do this. Sometimes that makes it a little bit simpler. If you're happy with having a few different methods depending on the scenario and you're doing them correctly, then that's absolutely fine. So I suppose my preference for this will be to use method 1, and that's the idea of squaring both sides. So when you see an inequality, when you see a modulus, regardless of whether it's an equation or an inequality, to get rid of it, we square both sides. Remember that the logic of this absolute value signs of these modulus lines, what they mean is whatever is in there should be taken as positive. So if it is negative, we take it as positive. However, if it's positive, we leave it as it is. And that's a little bit complicated for us because we can't just ignore them because we might have had to change the signs, and we get into this, what should we do? We don't know what we should do because we don't know what m is. So what we do instead is by squaring both sides is we create a positive number. So we 100% know it's positive because the square of any real number is positive, and that's some logic that we use quite a bit, especially when we're dealing with inequalities. So what we're going to do in this case, we're going to square both sides. Now, I know some people kind of started with this and then said it got very complicated very fast. And yes, it does, but we're going to work through it. So minus 12x plus 9 is equal to m squared x squared. So I'm using the shortcut. Square the first, twice the first by the second, square the last. Now, what we have here is a quadratic. It is a complicated looking quadratic, but it is a quadratic. And focus here on the idea of only one solution, and that's important. Quadratic of one solution, we should be thinking discriminant. Okay, so b squared minus 4ac, and when that is equal to 0, there's only one solution. So in order to use that, we're going to have to get it into a quadratic in a form we can work with. So we're going to have 4x squared, and we're going to bring the other x squared across, minus m squared x squared, minus 12x minus 2mx plus 9 minus 1 equals 0. So cleaning that up, I'm going to take the 4 minus m squared out in front of the x squared, minus, I'm going to put a plus here, and minus 12 minus 2m times x plus 8 equals 0. So yes, it's a bit complicated. However, we have a quadratic where this represents our a, this represents our b, and this represents our c. So we can use the idea of the discriminant, b squared minus 4ac equals 0. So b squared minus 12 minus 2m squared minus 4 times 4 minus m squared times c, which was 8. Working that out, so we have 144 plus 48m plus 4m squared minus 32 times 4 minus m squared is equal to 0. 144 plus 48m plus 4m squared minus 128 plus 32m squared equals 0. So let's clean that up. We have an m squared, an m, a number, and a number. So I'm just going to bring this up here. So we end up with 36m squared plus 48m plus 16 equals 0. Now to simplify this, we can divide across by 4. So you get, so we divide across by 4, we get 9m squared plus 12m plus 4 equals 0. So we can work with this using guide number or other factorization methods. Or if you want, you can use minus b. It's absolutely fine. And 2 plus. And you'll notice at this point that the two brackets are the same. And that makes sense because we only want one value for m. So the fact that we're only getting one value for m, that's exactly what we want. And it works out as minus 2 over 3. And at this point here, you might realize because we only want one value for m, we're probably going to get the same bracket, and this is actually a perfect square and can be written as a bracket squared. So by taking the square root of the first and the square root of the last, you'll be able to see that either. You can of course use minus b, there's no issue. And this does become a little bit more complicated than the second method, but I suppose you are at least starting it in the right direction. And what we tend to find is there's a lot of marks going for starting the question well and putting it in the right direction. Finishing it off, not so much. If you do something completely incorrect at the start of the question, you might end up with no marks because you haven't demonstrated any knowledge of how to work with the question you've been given. So I would just say make sure if you aren't using this method, if you're going to use the next method I'm going to show you, just make sure that you're comfortable when you use one and when you use the other. It is an important skill that you need to have to be able to work with quadratics that are not particularly nice. Especially if you look at this one here where there was 2x squareds where we needed to combine them to get a single coefficient. So this is a very, very good question. It's bringing a lot into it. It's asking a little bit about the modulus or the absolute value. It's asking a little bit that we need to use with the discriminant. It's asking a little bit we need about like just plain algebra of squaring brackets, simplifying and so on. So method 2 then is looking at using two separate linear equations. So the idea that the absolute value lines means whatever is within those must be positive. So if it's already positive, that's fine. If it's negative, then it has to change to a positive. So you end up with two different scenarios here. So scenario 1 is where this thing is already positive. So 2x minus 3 is positive and it's just equal to mx plus 1. The second scenario here is if that was negative. So if that was negative, effectively what's have to happen is the sign had to change. So it was equal to minus mx minus 1. However, the signs then change to make it positive. So we have two different linear equations here, and we want to find where there's m has only one solution. So there's only one value for m. So if we can isolate m in both cases, then they should be equal. So we have minus 3 minus 1 is equal to mx. So mx is equal to 2x minus 4. So m is equal to 2x minus 4 all over x. The other scenario here, we have 2x minus 3 plus 1 is equal to minus mx. So minus mx is equal to 2x minus 2, changing our signs. Mx is equal to minus 2x plus 2, and m is equal to minus 2x plus 2 all over x. Now, since there's only one solution, both of these would have to be equal. So therefore, 2x minus 4 all over x is equal to minus 2x plus 2 all over x. So getting rid of the fractions, multiply both sides by x, which gets rid of both of our x's here. And we're left with 2x minus 4 is equal to minus 2x plus 2. So 2x plus 2x is equal to 2 plus 4. So 4x is equal to 6. X is equal to 6 over 4, which is simplified down to 3 over 2. So that's our value for x. So then we have to go back and find our value for m. So we can use either equation here to sub it back in. So we say 2 times 3 over 2 minus 4 all over 3 over 2. And we're left here with 3 minus 4 all over 3 over 2. Gives us minus 1 over 3 over 2, which gives us minus 2 over 3 as our value for m.
So this is a mix of really algebra and working a little bit with Pythagoras, so sits kind of within the geometry trigonometry side, and there's a little bit as well with regards using Pythagoras, so really a geometry side in one part of the question, but it is predominantly an algebra question. So it says there are three natural numbers, a, b, and c, such that a squared plus b squared equals c squared are called Pythagorean triples. So we're used to this. That basically means it is a right angle triangle. So we have three numbers here that satisfy the fact they are a right angle triangle, where c is the longest side, the hypotenuse. When we can show this, they're called a Pythagorean triple. And we've seen that in other questions as well. So it said let a equal 2n plus 1, b equal 2n squared plus 2n, and c equal 2n squared plus 2n plus 1. Pick one natural number n and verify that the corresponding values of a, b, and c form a Pythagorean triple. Okay, so we need to pick first a natural number. So the easiest thing we can do is let n equal 1. That's the easiest natural number. Now, it doesn't matter what natural number you pick to use, but obviously we want to make our lives as easy as possible, and we'll do that by having the easiest number to work with. So the first number is a, which is 2n plus 1. So subbing in our 1, we get 2 times 1 plus 1, which gives us 3. Our b then is 2n squared plus 2n, which subbing in our values gives us 1 squared plus 2 times 1, that gives us 4. And then for c, we have 2n squared plus 2n plus 1. So that is 1 squared plus 2 times 1 plus 1, and that gives us 5. So we want to prove or verify. So they want to verify a squared plus b squared equals c squared. So let's take a look. So a is 3, so if I square that, plus 4 squared equals 5 squared. Now you might recognize that's actually one of our special triangles, so it is true, but let's work it through. 9 plus 16 equals 25. 25 equals 25. So that is true. So we'll just finish it off. Therefore, for n equals 1, which is the natural number we pick, A, B, and C form a Pythagorean triple. Great, so very straightforward. So they've now asked to prove that A, B, and C will always form a Pythagorean triple. So that's where n is an element of the natural numbers. So basically what we did in the last time is we picked a natural number and it worked. However, we can't say for sure that it would always work without testing all the natural numbers. The way we can work to make sure all the natural numbers work is work with them in the form that they have. So we have here, I'll just highlight each piece so we can see it. We have A, we have B, and we have C. So we want to prove that A squared plus B squared equals C squared. So let's work with that. So A squared. So A is 2n plus 1 squared plus B squared 2n squared plus 2n all to be squared is equal to 2n squared plus 2n plus 1 all to be squared. Now, there's a lot to do here. I suppose the left hand side is not so complicated if you're using the shortcut for squaring. The right hand side, we don't have a shortcut to square a bracket containing 3 terms, so we're going to have to multiply those 2 brackets out. So what I'm going to do, just to make my life a little bit easier, is I'm going to label this the left hand side and I'm going to label this one the right hand side, and I'm going to work with them separately. So let's work with the left hand side first and then I'll pull them back together at the end. So left hand side is 2n plus 1 squared plus 2n squared plus 2n all to be squared. So shortcut is square the first, 4n squared, plus twice the first by the second, plus 4n plus square the last. Same thing here, square the first plus 4n to the power of 4. So when we're squaring n squared, we get power of 4, plus twice the first by the second, so we get 8n cubed, plus square the last, 4n squared. Now we need to see, is there any kind of cleanup that we can do? And there is, because we have this 4n squared here and a 4n squared here. Other than that, we have no cleanup, so let's write it out. So we get 4n power of 4 plus 8n to the power of 3 plus 8n squared plus 4n plus 1. So now moving on to the right hand side, we want to square out that bracket. So we get 2n squared plus 2n plus 1 all to be squared. So we're going to write the bracket out twice. 2n squared plus 2n plus 1 by 2n squared plus 2n plus 1. Separating that out, we get 2n squared by the second bracket, 2n squared plus 2n plus 1, plus 2n by the bracket, 2n squared plus 2n plus 1, and finally plus 1, 2n squared plus 2n plus 1. So multiplying that out, we get 4n to the power of 4 plus 4n cubed plus 2n squared plus 4n cubed plus 4n plus 1. So bringing back the left hand side equals the right hand side. So we have 4n to the power of 4 plus 8n to the power of 3 plus 8n squared plus 4n plus 1, and that equals 4n to the power of 4 plus 8n to the power of 3 plus 8n squared plus 4n plus 1. Okay, so therefore a squared plus b squared does equal c squared. A, b, and c form Pythagorean triple for all n elements of n. So we've proven it there. So often when you have like a long multiplication like that, and if you look at that right hand side, it does get quite long. If you were trying to do that within the initial equation, it can get quite long and difficult. So do split